You can hear me? I'm assuming yes. Let's talk about Earth's frozen water. All right, so talked a little bit about it in topic 1. I talked about the Earth's fresh water supply and that basically 75% or 3/4 of the Earth's fresh water supply is locked up in ice sheets and glaciers. That's a huge amount of water. So a couple technical things to think about. Ice sheets, they're also known as continental glaciers, and they cover a vast amount of surface area. So for example, if you take the country of Greenland, I think it's 85% of that country is actually covered in an ice sheet, or sometimes they're referred to as a continental glacier. So continental glaciers are ice sheets. They're one and the same. It's just two different ways of calling them. Now, a glacier is much different than a continental glacier because glaciers, they can be very large, but once you get to the size of a continent, or I think it's 50,000 square kilometers, then you're considered a continental glacier or an ice sheet. So, fun fact here, or maybe a scary fact, depending on how you think about it, but if the world's largest ice sheet, which is in Antarctica, if it were to melt, the oceans would rise by 58 meters. So think about that for a second. Think about how large the oceans are and how high 58 meters is. That gives you an idea just how large that ice sheet must be in Antarctica. So ice ages, we're going to talk a little bit about ice ages, not the movie. Not this guy here who loves his acorn. We're going to talk about the ice ages throughout the history of the world, or Earth's history. So it's believed that there have been 7 ice ages over the last several million years, because the Earth is considered to be 64 billion years old. So I'm not sure how accurate those are, but they believe there have been 7 ice ages. We're going to go through some of the reasons why the world may have gone into an ice age. I don't think anybody knows for sure, but there's a few theories as to why the Earth would go into these long, cold periods for thousands and thousands of years. So let's talk about the first theory. The first theory is that there may have been occasional reductions in thermal energy. That's a fancy way of saying that the sun's heat seemed to diminish or become less for a period of time. That's one theory. Another theory is that there was increased volcanic activity, and you're thinking, well, volcanoes are hot, wouldn't that heat things up? It's actually the dust from the volcanoes would serve to block the sun's radiation or the sun's heat from getting to the Earth and reaching the Earth. So an increased amount of volcanic activity reduced the amount of the sun's energy reaching the Earth. That's theory number 2. Theory number 3, periods of mountain formation increased high altitude areas. Additionally, there is extra snow remaining on these cold peaks that reflects the sunlight. So we remember when we talked about light in Unit 3, we talked about how white reflects light away or reflects heat. Which is why when you go out in the sunshine, if you're wearing a black shirt, it's going to absorb. If you're wearing a white shirt, it's going to reflect. So if during these periods of time there was these high mountain ranges that were formed and it was reflecting away the sun's heat, I suppose that could also be a theory as to why the Earth's temperature dropped for a time and created an ice age. I like this theory personally, but they're all just theories. The next theory, the fourth one talked about in your textbook, is the movement of tectonic plates. Now, if you've never heard of a tectonic plates, I included this little image right here. So you can kind of see these little lines all around the globe, dividing the Earth into different sections. Now, basically underneath the ocean floor, underneath the ground we walk on, there is a series of tectonic plates that basically move very gradually and very slowly, and at times when a tectonic plates, and if you didn't know this already, when tectonic plates collide, that's what causes an earthquake. Now, with the movement of tectonic plates, there's a theory that says that the flow of the ocean currents changed up a little bit, and maybe there's less mixing of warm and cold waters. And so regions where they may have had warmer waters flowing by, maybe the temperature of the water was reduced because of the movement of these tectonic plates. And if you've ever been to, I don't know if you've ever been to like Victoria or just out to the west coast, there, depending where you put your foot in the water, it can be icy cold, or if you're in a bit of a bay, it can be a little bit warmer. But there's a clear difference between the temperatures in the areas where the ocean is really, really cold, or in areas where the ocean is very warm. It's going to change the temperature of the air as well. So that's one theory as well. And the last theory of the ice ages is the changes in the tilt of the Earth's axis. So the Earth is not perfectly up and down. It's kind of tilted on its side. And depending on how the Earth is, or how the tilt is, it changes it could change the proximity to the sun and therefore changing the temperature. Proximity meaning how near or far the Earth is to the sun. Just a slight tilt towards could make it hotter, or tilt away could make it colder. And so it produces ice ages in different regions. How the Earth's axis ever would have tilted, I don't know. But over the course of 64 billion years, perhaps that is a theory that could hold true. Are there any questions so far about the Ice Age?
Yes, Francis.
Oh,
Yes.
people. Oh, sorry.
So you said with the volcanoes and the ash would like make it colder and would block the sun's radiation or whatever.
Mm-hmm.
But in Hawaii, isn't there a lot of like volcanic?
There is, yeah.
And it's still really hot.
Yeah.
Is it just because it's closer to the equator, or would that not play a factor?
No, it definitely play a factor. It's kind of like if you look outside on a day like today, we've got these big dark clouds that are blocking all the sun from getting through, right? So obviously the temperature is going to be cooler than if it was a nice clear day, right? But yes, there's a lot of volcanic activity in a place like Hawaii, but that's just one of many places around the world. But just because there is active volcanoes doesn't mean they're all erupting at that time. Now, 64 billion years is a really long time. It could potentially be that there was some very large volcanoes that erupted, or like Mount St. Helens in Washington State that exploded, back in I think it was the late 70s or early 80s. And it sent ash up into the atmosphere, and ash from Mount St. Helens was found on the other side of the globe. If 2 or 3 or 4 of those situations happened kind of within the same period of time, it could potentially produce enough ash that it creates a big cloud of ash that does block UV light from getting to the Earth for an extended period of time, enough to send the Earth into an ice age. So it's just a theory, but what we see as far as volcanic activity in a place like Hawaii would not be enough for the Earth to go back into an ice age. Any other questions about those theories?
Yeah, I have a question.
Mm-hmm.
So, for those theories, the scientists, they think that it's all mostly to do with the sun, not something like cooling down the Earth's core.
Based on these theories, most of them relate to the sun. However, the tectonic plates thing, that has a little bit to do with going down towards the Earth's core, because sometimes a tectonic plate, if they collide like this, one tectonic plate is going to bend, and it usually bends down and goes down towards the Earth's core. Now, I don't know that that's going to influence the temperatures of the Earth, but most of these theories have to do with the radiation of the sun, whether it be a reduction in the amount of radiation coming from the sun, or a blockage or a reflection of the Earth's radiation from the sun. Okay. Now, you just need to be a little familiar with some of these different theories. It's, if you're familiar with those, that's good enough. Any other questions before we move on, guys? All right. So the last ice age, they figure it began about 120,000 years ago, but then ended about 11,000 years ago. Now, if you look at this little diagram or this figure right here, you can see in white, this is area that was once upon a time covered by ice. So it could extend it all the way down to the Great Lakes and even a little bit beyond those Great Lakes. So Alberta once was covered in ice. Probably more than once, but in the last ice age, Alberta, where we live now, was covered in ice. All right, so glacial movement. There's a couple things we need to know about glacial movement. First of all, how fast they move. It really depends on the glacier itself. The fastest moving glacier, I did a little bit of digging, the fastest moving glacier in the world moves 30 meters a day, to the point where you can almost see it moving, really. However, that's not average. On average, a glacier is going to move about 25 centimeters a day. There's another thing that happens. So we have glacier movement. So a glacier could be moving downhill. If it's moving forward downhill, that's called glacial advancing. If it is moving backwards, it may still be moving downhill, if it probably is, but what's happening is the glacier is melting faster than it is sliding down the hill. So if it looks like it is actually moving uphill, it's not. It's just melting faster than it's actually moving downhill. So, speaking of glacial advancing, it simply refers to a glacier moving downhill as it's being acted on by gravity. Okay? So that's one term that you need to know. I'm going to go through about 5 terms that I want you to be familiar with here, okay? Stream table. This isn't a term from your textbook, but this is something that you'll see in a couple of the questions. You need to know what a stream table is in order to understand the questions. Okay, so stream table kind of looks like this. Inside this table, different sediments are put, like sand, dirt, silt, clay, rocks, and then basically water or ice or other substances are made to flow down across that surface. As that happens, it's used to demonstrate basically how water, wind, glaciers, and stuff can affect a landscape. Okay, so that's called a stream table. All right? Now, another term to know is meltwater. So it's really pretty much as straightforward as it sounds. So it's water that gets released by the melting of snow or ice. So if you were to see a little puddle up of ice at the top of a glacier, well, that's just meltwater simply. That meltwater is going to trickle down through the cracks and the crevasses and everything like that, and it's going to make its way down to the ocean, right? But that's just simply meltwater. Another term to know, see, when glaciers move, they kind of work like bulldozers. They're going to pick up rocks, clay, dirt, silt. They're going to pick up all sorts of sediment as they move down the mountains. Now, when they stop or they slow down, they're going to dump a bunch of the stuff that they've picked up. That stuff is called till. So till is characterized as a jumble of rocks, sand, rocks, clay, silt, deposited by the glacier. So it's really a mixture of different sized sediments. So if it were all the same size, that would be something different. But something that is a jumble of different sized sediment, that would be called till. Another term to know would be pack ice. So pack ice it's just large pieces of floating ice that have driven together into nearly a continuous mass. So you see this in your polar or your northern seas. They get covered over by ice for a season, and then they melt away during the summer or the warmer months, and then it gets covered over again by this pack ice. So you have an image here of what pack ice looks like. Couple things here. Here's an iceberg. You can see what's happening here. I wanted to get a picture of an iceberg breaking away from a continental glacier. So here we have an iceberg that is breaking away, or we call it calving, from a continental glacier. So if it calves, it just simply means it breaks away. Now, glaciers float in the ocean, but a lot of people don't realize that their origin is from a continental glacier, having broken away from a continental glacier. Now, icebergs can be massive, absolutely massive, right? It can almost look like its own little island because they're so massive at times, right? So, does this look familiar to anyone right here, this area? If you're reading the text, probably don't need to think too hard. So that's Glacier National Park. So if you've ever driven into Kalispell area or Whitefish from the I'm taking the Going to the Sun Road, it's a really high mountain road. And when you're driving along there, you're going to see these big U-shaped valleys that are evidence of glaciers having existed there once upon a time. Now, what you need to take away from this is that glaciers, when they travel, they're going to carve out U-shaped valleys. So you can see very clearly here, this is a U-shaped valley, right? So that's why they call it Glacier National Park. Imagine that, eh? Now, let's look at this next picture here. Bentley, maybe you should come watch this. So what do you notice about the shape of this valley here? Does it look like the last one we looked at? Or is it a little bit different? Are you guys still with me? Anyone? Oh, good.
That one's in the shape of a V.
Yeah, it's in the shape of a V. And so what do we know about a valley that when it's formed in the shape of a V, it was carved out in a different way? What forms valleys that are shaped in a V? Those of you, yeah, okay, so you obviously did your notes, right? So yeah, V-shaped valleys, those are formed by rivers running through them, and then erosion over time eventually wears them down more and more to the point where you have this V-shaped valley. If you think about how many years old the earth is for you to be able to erode away a valley that much. We see rivers, and you go back to those rivers 10 years later and it doesn't look like anything's changed, right? Well, 64 billion years is a lot more than 10 years. So 64 billion years from now, I'm sure the earth's landscape will look that much different as well. All right, so I'm just going to compare these two. So again, you see the U-shaped valleys formed by glaciers, and you have the V-shaped valleys formed by rivers. The last thing that we are going to talk about, and this is something we talked about only a few topics ago in Unit 4, we talked about climate changes and what's happening. We talked a little bit about the greenhouse effect, and we also mentioned that the greenhouse effect is not a bad thing. In fact, if we didn't have a greenhouse effect here on Earth, we would actually all be dead. We'd be frozen to death. Okay? Because the Earth's atmosphere, it allows rays of sunlight to come in, and then it traps that heat in the Earth's atmosphere. And if it didn't do that, we would freeze to death. Okay? Now, the greenhouse effect, in that sense, is necessary. However, an overabundance of greenhouse gases, it can throw things out of whack on the Earth. And one of the things that scientists believe is a cause of global climate changes or global warming is an excess of carbon dioxide in the Earth's atmosphere. And as we learned about in Unit 4, carbon dioxide, which is a byproduct of fossil fuel combustion, so we burn gas or diesel in our vehicles, one of the byproducts is carbon dioxide. That carbon dioxide goes into our atmosphere. And because it is an excess of what is normally in our atmosphere, it is believed that it is causing a rise in our mean temperature. And over the last 100 years, and this was 20 years ago, the Earth's mean temperature, so the average temperature, has risen by 0.5 degrees Celsius in the last 100 years. Now, 0.5 degrees Celsius doesn't sound like much, but there are very delicate balances everywhere when it comes to our Earth. All right, I'm going to open up questions from you? Are there any questions that you might have for me about?
Can you go back to the stream table slide?
Sure.
I can finish writing down the definition.
Yeah,
Thanks.
I will go back to that for sure. Now, you're not being asked to tell me what a stream table is. You just need to know what it is so that you can kind of explain another concept, right? So the question would read something like, Sophie uses a stream table to perform this task. And if you don't know what a stream table is, it might be difficult for you to understand what the question is asking. Any other questions? Again, all of this stuff it's in your textbook as well. So take your time when you do your quiz, guys, and I think that the information that I shared with you here is probably going to be very applicable to the questions that'll be on your quiz as usual. You're allowed to go back and watch the video that I'll post about this as well, so feel free to do all of those things and ensure yourself a great mark. You guys can still raise your marks from the first 3 quarters, right? So keep that in mind. Any other questions from anyone else? Was that Haley who asked about the stream table?
Yep.
Okay, thought I recognized the voice, but I'm not seeing faces as I'm on this page here, so I'm just guessing. All right, well, I'm just gonna go back to our meet here and away from that presentation here. Hey, Donald, you're a little late to the party, but I'm going to post this video, okay? Jacob, any questions from you? Okay. Haley, you're good? Jaron? All right. Let's see what else we got here. Alice, any questions for me?
Nope.
Brittany? Brody?
No, I don't have any.
Okay. Colin, any questions for me? Wow, I think you're speaking too close to your mic. Dane, any questions for me?
No.
Okay.